Good morning, guys. Welcome to Videos Olakan tutorial. Thanks for watching our videos online. Please don't subscribe, please click the subscribe button and notification bell. That's our updates on this YouTube channel. Thank you and God bless you. Amen. Today we'll be considering what? The topic 2 under physical what? Quantity, other subjects called physics. And today I will be considering dimensions and dimensional analysis. Dimension and dimensional analysis. Now, when I talk about dimension has to do with what? Physical quantity. And we said in our previous video that quantity has to do with the measurable property of a substance, such as height, weight, mass, and so on. Something that you can quantify in a what? In an object is what we call what? Is what we call quantity. Now, we have talked about the units of each physical quantity. Now we are going to be talking about the dimension of quantity, of different quantity. And here we are going to first talk about the three fundamental quantity, three basic fundamental quantity. What are the dimensions of the three basic fundamental quantity? The dimension of the three basic fundamental quantity, the dimensions of three basic of the three what? Of the three basic fundamental quantity, of the three basic fundamental quantity. Now, if you watch the previous video, and I know I mentioned three basic fundamental quantity out of the what? The 7 fundamental quantity that we have. There are 3 that are basic, which are what? Which are the mass, the length, and the what? And the time. These are the 3 basic fundamental quantity out of the 7 fundamental quantity that we have. And the dimension of these 3 basic fundamental quantity are capital letter M, capital letter L, and capital letter what? T. So now these are the basic fundamental quantity and their dimensions. And we are going to be using these 3 basic dimension to use. We are going to be using it to analyze the other physical quantity. And that's what we call dimensional analysis. And dimensional analysis can be defined as the way by which other physical quantity, usually the derived quantity, related to what? To the dimension of mass, length, and what? And time. I repeat myself again. I said that dimensional analysis can be defined as the way by which other physical quantity is related to the dimension of mass, length, and time. And what are the dimension of mass, length, and time? MLT. So the process by which we relate the quantity, other quantity, in terms of what? In terms of MLT is what we call dimensional analysis. And I will quickly go to that now by using we are finding the dimensional analysis of some physical quantity. So, and how do you go about that? Dimensional analysis of some physical quantity. Dimensional analysis. The dimensional analysis of some physical quantity. The dimensional analysis of some physical quantity. Please follow. Now we are going to be having our table. I usually like to present this in table. So this is the quantity, the formula, and then the dimensions. So we have the serial number column. We have the physical quantity column, which is derived quantity. The physical quantity that we are considering here is derived quantity. Let me just use general name, which is quantity. Then we have the formula for the quantity. Then the dimension analysis, the dimensional analysis of it. Then the dimensional analysis of of that quantity, and then the dimensions. So now we have we have number 1. I'll talk about area. I know we have discussed this under unit as well, but this one we are talking about the dimension analysis of area. We know that the formula for obtaining area of a substance, usually the area of a rectangle here, or the area of the square is usually the length times what? Breadth. The length times breadth. Where this breadth also represents length in physics. Like we can take it to what? We can take it as what? As meter, because the measurement of what? Of breadth is also in what? In meter. So because of that, the dimension of length is known as what? L. And dimension of breadth, because it's also measured in meter, it's also taken as what? L. So we have L times L equal to what? L squared. So the dimension of what? Of area is L squared. While the way we analyze it is L times L. So the dimension itself is what? Is L squared. Do we get that? So now let me just take it to, you have the dimensional analysis here, dimensional analysis here, then the dimensions. So as you know, the dimensions. So the dimension here is L squared. So how do we get that? L times L, which is equal to L squared. So the dimension here of the area is what? L squared. Now we move to the next one. The next one is what? Is volume. Let's consider volume. Volume of an object is usually the volume of an object, especially when we are talking about what? Keyboard. We have what? Length times breadth times what? Height. Length times breadth times height. Please follow. We have the what? The length is measured in what? Length. So that's why the what? The length is measured in meter. That's why the what? Dimension is what? L. The breadth also is measured in meter. Dimension is what? L. And height also in meter. Dimension is also L. So what we have here is equal to L cube. Therefore, the dimension is also what? L what? Cube. Do we get that? So now we move to the other what? The other aspect, which is what? Which is the what? You can take this one as well. You can take density if you want to. Let's quickly go into density. Density has to be what? The formula of density is what? Mass of a substance per volume. The mass of a substance per unit volume is equal to what? So the dimension of mass is what? Is capital letter M. Don't forget that the dimension of mass, length, and time are M, L, T respectively. So dimension of mass is M, while the what? The volume is what? The volume here has been calculated, which is what? L cube. You see, volume L cube. So by combining the two together, we are going to have L per cube, because this is going to go up. This is going to go up. It's going to go up because according to the law of indices, when something of power goes up, so it will become minus what? 3. So we have what? The speed and then the what? The velocity. Now why am I combining the speed and the velocity together? Because the speed and velocity have the same unit. They have the same unit. It is meter per second, but they are different quantity. One is scalar, the other one is what? Vector. But actually their unit is the same thing, and that's why I'm slashing it. They have the same dimension. So if they say what's the dimension of speed, the dimension of speed is the same as the dimension of velocity. So don't be confused, because they have the same unit. The only difference is that one is scalar, which is speed, and the other one is what? Vector, because this one is distance over time, while this one is displacement over what? Time. So what am I trying to say now? So we are going to combine the formula together by saying distance or displacement, or what? Displacement all over what? Time. That is the change in distance all over change in time. So now we have what? We have the L, which is L is used to what? Represent both distance and what? And displacement in terms of dimension, because they are both what? Measured in meter. So L all over what? T. So by so doing, you take this one up as well. It will come, because it's power of 1, so it's going to be what? L per T. So the power of 1 will become minus 1 when it gets up. No, so the other one is what? We have what? The acceleration. Both the acceleration or acceleration due to gravity, or acceleration due to gravity. So don't be confused. Acceleration due to gravity and what? And acceleration, they are what? The same thing. Acceleration, their units, their dimension are the same thing. Please note that. So acceleration or acceleration due to gravity. The acceleration is represented by A, while the what? The acceleration due to gravity is represented by G. Please note that. That's why we are doing this what? Or let me just, acceleration is represented by A. The acceleration is represented by what? A. Why the what? Let me put O here. Acceleration or acceleration due to gravity. While acceleration due to gravity is represented by what? By G. So now acceleration due to gravity, it's what? Acceleration itself is velocity over what? Time. Please note that. The acceleration or acceleration due to gravity, we can take it as velocity over time, which is what? Which is L per T all over T. And this is T raised to power 1. So when it comes up, it becomes what? Minus 1. So it's going to be what? L per T minus 1 minus 1. So we have L per T squared. Please note that L per T squared. Acceleration or what? Acceleration due to what? Gravity. Acceleration or acceleration due to gravity. So now the next one is what now? The next one is now the force, because that's how I'm going. We have the force. The force is given as mass times acceleration. Mass times acceleration, which is m multiplied by what? L per T squared. Why? L per T squared is the acceleration. So the dimension will now be what? ml per T squared. It's very, very important you know all these things. So that's why I'm writing the dimension here, so that whenever you wanted to record for it, you can actually what? You can actually have access to it directly. So 7, we have what? We have the what? The pressure. So back to pressure now, which is what? Force over what? Area. Force over area. Force over area is same times what? Now, what's your force? Your force is ml per T squared all over what? Your area, L what? Square. L squared. So by doing so now, you can say ml1 raised to power 1. This one is raised to power 1. When this one goes to the ground, minus 2 per T squared. You can see, please, sorry for not writing it very words. So this is T, this is T. So this is M L raised to power 1 minus 2, T raised to power minus 2. So everything here we give what? M L raised to power minus 1, because 1 minus 2 we give a minus 1. Then we have T raised to power minus what? 2. So that's that about that. So the next one is what? The next one is the what? We have the work done, which is what? Force times distance moved by the what? Force. Force times distance moved by the what? Force. So I will take it as distance. This force times distance moved by the force. We have what? What is our force? Our force is m L per T squared multiplied by what? Distance, which is L. Now look at this. The law of physics says that whenever you are having the same base, L, it will be what? This one is power of 1, power of 1. It will be power 1 plus power 1. It will be now what? Okay, let me do it. Here, this is supposed to be the final dimensions. So let's do it here. That's how we do L. Please look at this. L raised to power 1 plus 1 because of this one here. So L times L will be what? L squared. You don't know it as that. You can start to use what? L times L, which is L squared. Or use law of physics, which says whenever you have the same base, to 1 plus 1. Do we get that? So that is what? That is T raised to power minus 2, which is the same thing as what? Now the final answer here will now be what? L raised to power 2, T raised to power minus 2. Please note that L raised to power what? 1 plus 1 is L raised to power 2, T raised to power minus 2. If you cannot do that, just say L times L to give you L what? Square. then per t squared. Do we get that? So that's that. So now, number 9, we have what? The last one is the last one that we can actually what consider. So the watt, which is same as the power, the unit of power is watt. The unit of power is watt. That's why I write watt in the first place. So power has to do with work done all over what? All over time. Work done all over time. So when we're talking about work done all over time, so it has to do with what? M raised to power L squared t raised to power minus 2. We can see that the work done that we get here is LL squared per what? Per t squared. So then from here all over what? Time, which is t. So meaning that this one will also go up, making it minus 1. So it will now be what? It will be LL squared per t 1. How do I per t3? So how do I get that? This one become minus 1. It's going to be what? Minus 2 minus 1. So it's going to be minus 3. I repeat myself. This one go up, it will become minus 1. So it's going to be what? Minus 2 minus 1, which is what? Minus what? 3. So don't worry, we haven't getting this one, and we are going to consider the what? The questions after, so as to be able to get the explanation very well. So that's that about the dimension of some physical quantity, usually what? The derived word quantity. So let's move to the what? Calculation thereafter. Solution to some selected past question. Now, so this they are going to consider solution to some selected past question. So now the first question here says that which of the following dimension represents impulse? Which of the following dimension represents impulse? Now the first thing that ought to come to your mind is that what is impulse? What is impulse? Well, how can we express impulse? Now impulse is equal to force times time. That is the formula for impulse. Force times what? Time. So now if you go to our dimension table, you know that our force is mn per t squared. How? Because this is mass. Force is mass times acceleration. Force is mass times what? Acceleration. So it is mass is kilogram, acceleration is L per t squared. So and the time itself is what? Is t. The time itself is t. So and this is just power 1. So by doing so, we're going to have what? ml per t. Now because it is multiplication, the relationship between this what? This t and t is multiplication is going to be plus what? 1. So we are going to have ml per minus 2 plus 1. It's going to give me minus 1. So that's why your per t. So that's that about that. That's that about that. So that's that about that. So ml per t. ml per t. So that's that option B. You can see this one is option B. So it's option B. So ml per what? T. Please note that. So we are talking about what? Solution towards some selected questions. So that's number 1 for you. So number 2. So number 2 is the dimension of momentum. The dimension of momentum. You see, we are going to arrive at the same answer here because the dimension of momentum and impulse are the same thing. The dimension of momentum, especially the change in momentum, are what? The same thing. The dimension of momentum and impulse is the same thing. But let's go through it. What is momentum? Momentum is just simply simply mass times velocity. Mass times velocity, which is equal to what? Mass times velocity is equal to m multiplied by what? M, the kilogram, dimension of mass is m. While the dimension of what? Of velocity is L per t. You can check the table or fast forward or rewind the old videos, rather rewind the video and check the table for velocity, dimension of velocity, which is what? L per t. M times L per t is going to be what? M L per t. You can see they are the same thing. M L per t. M L per t. They are the same thing because the change in velocity, the change in momentum rather, change in momentum. Why? Because change in momentum is equal to what? Impulse. The change in momentum is equal to what? Impulse. According to what? According to change in momentum is equal to what? Impulse. According to Newton's second law of what? Motion. Newton's second law of motion. How do I know that? According to Newton's second law of motion, which says what? Change in, it says F into bracket U V minus U equal to what? Ft. So if you make, this is what? This is the summary of what? Newton's what? Law of motion. If you make F solve the formula, you are going to get what? F equal to M into bracket V minus U all over what? T. But I'm not going to that later. We are going to be talking about Newton's law of what? Motion. So that's why they have the same what? The same dimension, because their formulas are equal to each other. You can see mv, mass times velocity, that is change in velocity. Mass times velocity is here, then force times time, which is this, is here. So that's why we have the same dimension. So number 3 here is what? At what respective value of x, y, and z, at what respective value of x, y, and z will the unit of force, Newton, be dimensionally equivalent to MLT? Now, they say at what value of x, y, and what? And z will the unit of force Newton is dimensionally correct? All you just need to do is what? Just put LT here and apply x, y, z and equal it to what? The dimension of the force. Equate it to the dimension of the force, which is simply is what? Lx, Ly, T, Z. This is Tz equal to, now what's the dimension of force? Is mL per t squared. Now, if you relate it very well, this one is going to be 1, 1. Abi? Therefore, x is going to be 1, y equal to 1, and then z is equal to minus 2. So it is 1, 1 minus what? 2. What? 4. Which says the dimension of electromotive force are Now, what do I mean by electromotive force? You must first know the formula of what you are dealing with. You are dealing with electromotive force, so you have to recall for electromotive force. What is electromotive force? It is the work done. It is the work done per unit what? Coulomb of a charge between two terminal. The work done performed by a unit what? By a unit coulomb of charge between two terminal. The work done performed by a unit coulomb of charge between two terminal of a conducting wire. Now that is electromotive force, and usually denoted by what? E, which is equal to what? The work done all over the quantity of charge. The quantity of charge Q. The quantity of charge Q. Let me write the quantity of charge. Very, very important. Quantity of charge. So meaning that W all over what? Q is the formula. Now E. Now recall for the formula of work done. Work done is force times what? Distance. Or don't let me even what? Express it in that way, because we have already done the work done, the dimension of the work done in the previous video, in the previous explanation which I did in the same video. So the dimension of the work done from the table that we just draw, now it's going to be what? M what? Let's look at it. Okay, let's do it together because I cannot even remember. So the dimension of what? Of W now will be E equal to Force times what? The formula, let me do it again. Force times distance. All over what? The what? The Q itself is what? IT. Q is IT, is given as what? Time. That is current times time. Now, the formula for work done is force times distance. The formula for current is for quantity of charge is current times time. Meaning that what? I'm going to have force. Dimension of force is L per T squared times the distance, which is length L, all over. The current is, dimension of current is I. Current is part of the word fundamental word quantity, but not part of basic fundamental quantity. Please know that. Current is part of fundamental quantity, not basic fundamental quantity. So we have what? I. So I times what? T. So, and so doing now, we can now try and arrange it. So we have T here, so T can come here. We have L per minus 2. And this one is minus, this one is 1. When it comes, so it becomes minus 1. Then Li, when it also comes up, it goes to minus 1. So minus, okay, Li does not come up, please. Li is still up, but let's take it one by one. So ML T raised power minus 2 minus 1 by this, and we still have what? L here, all over what? I. Let me take it one by one so that it will not be confusing. So now I just took this one now. It's going to be M. Now L per minus 3 L all over what? I. Now you can easily multiply this one together to give what? L squared. So L squared. You get it? T raised to power minus 3. Then I will now comes up. I will now comes up. I raised to power minus 1. Please know that. So I've done something here. So this is T raised to power minus 3 here. T raised to power minus 3 L all over T. So from here now, L multiplied by L, it becomes L squared. Then I comes up to become I inverse. Please don't be confused. It's very, very what? Simple. So we have what? Option B. So that's that about that. Now that's that about some selected past questions under dimensions. Now we're going to go into theory as 5 is actually in theory form. This question number 5 is actually in theory form. And the question goes thus: the velocity v of a wave in a stretched string. The velocity v of a wave in a stretched spring depends on the tension in the spring. Depends on the what? Look at this. The velocity what? V of a wave in a stretched spring depends on the tension in the spring and the mass units and the mass per unit length mu. It depends on the tension in the spring and the mass per unit length mu of the spring. Obtain the expression in terms of T and nu using the method of dimension. Obtain the expression in what? In terms of T and nu using the method of dimension. So it's supposed to be expression. Now we are going to be talking about how to express this information in terms of dimension. In terms of what? Dimensions. Now we are told that what? The velocity is equal to velocity of the wave depends. Please know that the velocity of the wave depends. When something depends, it means it's proportional. It's proportional. The V depends means it's proportional, and it dependent might be in terms of what? Direct and inverse. In terms of direct and inverse. And since they are not mentioning the type of proportionality here, we are going to take it as what? Direct. Please know that they say it depends. They didn't tell us it's inversely proportional. So it depends on. So we take it as directly proportional. So V is directly proportional. That is, V is depending directly on what? On the tension T. On the tension T, and the mass per unit length, which is known as what? Mu, multiplied by mu. But they divide the mu for us. Now they divide the mu for us, but before we get there, we are going to express this as what? As an equation. We take it from variation. This is a variation. We take it to what? Equation, which is V equal to K T and what? Mu. V equal to K times T times mu. And what you are going to do now to get the dimension is going to be V equal to what? K is a constant, so you don't need to what? Put any unit, you don't need to put anything on it. So you are going to attach S here. Mu, you attach what? Y. Please note that because we are trying to get an expression, we don't need the power of T, we need the power of what? Mu. So now, and this is where this is where you are going to record for the dimension of T and mu. Now, tension T is a type of what? Force in rope, string, or spring. So you know that T here is a type of force, not time. So it's a type of force. It's not like the T is representing a type of force, which is a force in rope, string, and what? Spring. So you are going to find the dimension of force for T that's representing tension. So now I want to find the dimension of force that is being represented by T, called tension. So what's the dimension of what? Of force. So the dimension of force, knowing fully well that what? The dimension of force will now be what? T is equal to ml per T squared. From the table, you can quickly go there and check dimension of force. ml per T squared. So that's how to call it, ml per T squared. So that's that for the dimension of the tension force. So now the other one is mu. You need to get that mu. Mu, according to the question, is given as mass all over what? Length. Whenever you hear about what? Per means divided by. Per means divided by. So it means mass over length, which is what? Capital letter M all over L. So the dimension is simply M per L. M per L. So you now go back and put this into this equation. So we have V. And lastly, the dimension of V is L per T. It's very important. We are going to substitute this dimension into this equation. So putting this word, these dimensions of each quantity inside this equation, we now have what? L per what? Putting what? Put the what? Dimension of individual what? Individual quantity in equation 1. We call this, let's call this one equation 1. Equation 1 in equation 1. So put the dimensions of individual quantity in equation 1. So we have the V is what? L per T equal to K is a constant. So the dimension of what? T is ml per T squared into bracket what? X. Don't forget ml per T squared bracket what? X. Into bracket as well. Mu is what? Mu is M per L all over what? This per Y, this per Y. So we have what? L. Now, this is L per T equal to K. You can easily multiply this one out and say this one is L, because it's like 1. So it's going to be what? L 1 times x equals m raised power x, L raised power x, T raised power minus 2x. Then the same thing happens here, m raised power y, L raised power minus what? Y. Alright, communicating. Now, you can see m is on this side, m is not on this side. Just introduce m raised power 0 equal to m raised power 0 L per T. M raised power 0 is the same thing as 1, so it does not affect this. We are just introducing 0 so as to what? Be able to solve this what? Expression. So m raised power 0, then we have k raised power open bracket. Now you are going to arrange now. Make m comes together into bracket m x. Now because of multiplication that is in between them, and the law of this is whenever we have the same, the law of this says that whenever we have the same base, whenever you have the same base, you can add the power. This is you can add x plus y, and their relationship is multiplication. So instead of what, this is the law. The law says that whenever we have x to the power a multiplied by x to the power b, it's going to be x to the power a plus b. Please note that that's the law. X to the power a times x to the power b equals x to the power a plus b. So we're having m x to the power x multiplied by m x to the power y. It's going to be m x to the power x plus y. M is to the power x plus y. So for this m, that is for the n. Now for the l raised to the power x. Now m raised to the power what? X is supposed to be plus into bracket what? This is supposed to be plus into bracket minus y. So that would be x minus y. It's going to become x minus y. So bracket close. Then the last one is t. T raised to the power minus 2x. It still remains t raised to the power minus 2x because it does not have any partner. So that's that. So I will clean this one. I hope I've gotten it. So with that now, let me quickly finish this. So here now we can easily what? Now have, you can easily now substitute now. Don't forget that we have m here now. We now say equate the equation, equate the left hand side to the right hand side. That is in terms of power. Equate the what? The left hand side and the right hand side in terms of what? In terms of their power. In terms of their power. In terms of their power. Now, what do I mean by that? M, we are having m here, we have 0. The power of m here is what? 0. So we have 0 equal to what? 0 is equal to x plus y. Call it equation 1. Now, L here has power of 1 in the left hand side. So we have L have power of 1 equal to, now x plus minus y. X plus minus y, plus times minus will give you minus. So it's the same as x minus y. So we have x minus y equation what? 2. So, and the last one is what? T raised to the power minus 1. T raised to the power minus 1 equal to what? Minus 2x. Equation what? 3. Equation 3. So that was what I mean by equating the L left hand side and the right hand side in terms of power. So the next thing you are going to do now is to actually what? Now solve this simultaneously, starting from what? Equation 1. Why am I starting from equation 3? I'm starting from equation 3. Why? Because this is the what? Simplest what? Equation that we have here. This one is these are simultaneous equations. But this one is a what? Is a linear equation containing one unknown. So we have what? F from equation 1 now. From equation 3 rather. From equation 3. From equation 3. What do we have? We have minus 1. Minus 1 equal to minus 2x. Minus 1 equals minus 2x. So what you do here is you divide both sides. Divide both sides. Divide both sides by what? Minus 2. So therefore we have minus 1 over minus 2. Divide both sides by minus 2. So that's what I'm doing here. So minus 2x divided by minus what? 2. Please follow. Divide both sides by minus 2. I put column here minus 2. Minus 1 divided by minus 2. Minus 2x divided by minus what? 2. So we have minus 2 cancel minus 2. So minus cancel minus. We have x here equal to 1 over 2. So therefore x is equal to 1 over 2. X is equal to 1 over 2. So that's how we get x equal to 1 over 2. Then by so doing now, we now substitute this x into equation 1. Substitute 1 over 2 for what? x. Substitute 1 over 2 for x. So in equation what? In equation 1. I'm going for equation 1. Substitute what? Substitute 1 over 2 for x in equation 1. So what is equation 1? Equation 1 is 0 equal to x plus y. So 0 is equal to 1 over what? 2 plus y. So when you transfer the minus 2 to the other side, when you transfer 1 over 2 to the other side, it's going to be what? 0 minus 1 over 2 equal to y. Therefore, y is equal to what? Minus 1 over what? 2. So x is 1 over 2, y is equal to minus 1 over 2. Now, if we check whether you are correct from equation 3, let's check whether we are correct from equation 3. So checking now, I'm just checking. Check whether we get the right answer for x and y by going to equation 3. So from equation 3 now, equation 2. From equation 2 says 1 equal to what? X minus y. Let's see whether it's true. Y is equal to what? 1 equal to x minus y. Let's see whether it is true. Let's see whether it is true. X minus y, they said it is equal to 1. Let's see. What is your x? X is 1 over 2 minus, what's your y? Minus 1 over 2. So 1 over 2 minus 1 over 2. X minus y is same as 1 over 2 minus 1 over 2, because x is 1 over 2. And minus separate them, minus 1 over 2. So it becomes plus. So it becomes plus. So therefore 1 over 2 plus 1 over 2 equal to 1. You can see that we can confirm that our answer is what? Correct. Since we get 1, it means that our x and y are very much what? Correct. So that's that about that. So this is just a checking for us. Now you now go back to the expression itself. As I said, that this is theoretical questions under dimension. It's a theoretical question under dimension. So don't be disturbed. Just follow the procedure and watch over the video over and again. Watch over until you get the procedure used here. So now we have what? We have our x to be 1 over 2 and our y to be minus 1 over what? 2. Our x is what? 1 over 2 and our y is minus 1 over 2. So, and how do we do that? How do we do the final steps? How do we carry out the final steps? So from the expression that we get here, which is v equal to k t raised to power x mu raised to power y, we now say, okay, since we have our what? Our v and x, v will be equal to k t. What's our x? Our x is same as 1 over what? 2. Y mu raised to power y, which is minus 1 over what? 2. So according to the law of indices, you can easily say v is equal to k. Now anything raised to power r means root that thing. So with t equal to, now this one is inverse law. We have inverse law. Anything raised to power minus, anything raised to power minus that, anything raised to power minus is going to be 1 all over. So this is having minus as its power. So it's going to be 1. One thing about this thing is that if you don't know the law of indices, it might be difficult for you to really get. So we can see that this is multiplication that is in between them. When you see there is no anything there, it is multiplication and represented by what? Dot. So root t multiplied by 1. This 1 is a result of what? This minus as the power. 1 all over root 1 all over mu raised to power half. So which can be equal to t. It can be equal to k root t times 1 over root u. Did I call it u? 1 over root mu. So k root t times 1 over root mu. So with that now we can now say v is equal to k times this one, it will be k root t all over root mu, which is equal to k root t all over mu. So that's the final expression. The final expression is k root t all over mu. That's the final expression. This is what we are asked to what? Look for. It might be time consuming, but it's very, very what? Simple. Only if we can watch over the video all over again and then try some what? Examples that will be drawn below the what? The comment. So that's that about question number 5 that involves theoretical aspect of dimensional analysis. This is a Waec 2020 past what? Question. So now let's quickly go to 6 and 6. Number 6 question now. Which of the following quantity has same unit as what? Which of the quantity has the same unit as what? What? Now, the first thing to come to your mind is that which quantity has the unit of what? The first thing that you ought to come to your mind as far as question number 6 is concerned is which of the quantity has what? Which of the quantity has its unit to be what? What? So, and the only power is the unit, is what? Is the quantity with unit what? With unit what? That is W. Power is the quantity with unit watt. So that's the way to start. Then you now begin to what? Say, okay, what is the formula for power? That's the next thing. What is the formula for power? Power can be calculated as work done over time. Work done over time. All over time. So, but it's not here. So, we need that what? This is now the formula they are requesting for. So, another formula for power is force times velocity. That is force times velocity. That is Fv. Now, if you find out their units, you will see they are the same thing and the result in what? In watt. Like this one is, we have done it before the other time, but this one is going to give you what? The same unit as what? As this. Let's look into it to confirm that, not just to be saying it theoretically. So P here, let me do this one for. This one is going to be what? Force times distance all over what? Time, right? You can even see that they are the same thing. Force times distance all over time. This is force times distance all over time. If we take what? If you take distance, the work done is force times distance. If you take this force multiplied by distance all over time, they will give you what? It will give you what? Speed, which is same times velocity. So you can easily say that Fv. So that's how we get Fv, because force times what? Force times distance over time, which is same times what? Velocity. So we can say that this formula, work done, can be expressed as Fv. Do we get that now? So the answer here is force times velocity. I hope I've answered your questions. Work done is equal to power is equal to work done over what? Time, and work done is force times distance over time. So rearranging in such a way that we have F times distance over time. Distance over time is equal to speed, and speed and velocity have the same what? Unit. So it can also be what? Displacement all over time. So the difference between distance and displacement is just that one is what? One is vector quantity and one is what? Scalar quantity. This one is vector quantity, this one is scalar, this one is scalar, this one is scalar, which is distance, and this one is what? Vector, which is what? Displacement. So don't be convinced about that. I don't want to take much of our time on this video. This one is what? Distance. It's not having what? This one is just having 2 meters. This one is having 2 meters and a direction. 2 meters. Go and watch my video. 2 meters and a direction. Direction, not eastward. So that's why. But they can be used interchangeably. You can see distance. They put what? Displacement there, because they are both measured in meter, but they are not the same. So that's why speed and velocity can also be used interchangeably. So instead of me putting distance now, I can just try to use what? Displacement. So it does not matter. So that's that about that as far as what work done is concerned and power is concerned. So the option here is force times velocity. So, number 7 says the International Agri System of Units (SI) for physical measurements are International Agri System of Units (SI) for physical measurements are IB, feet, seconds, gram, meter, seconds, kilogram, meter, second, centimeter, gram, seconds. You can see that this is an SI unit because it is containing kilogram, meter, and then seconds. The kilogram is for mass. The SI unit, the SI unit kilogram is for mass. The SI unit meter is for length. The SI unit seconds is for time. So this is an international system of measurement, that is SI. So it's the only one that is acceptable globally in physics. So kilogram, meter, and seconds. And these are the fundamental units. They are called fundamental units because they belong to what? Fundamental quantity. So we have come to the end of today's class. Please, if you haven't subscribed, please do press the subscribe button and notification bell. That's all our updates on this YouTube channel. Thanks for watching once again. Thank you and God bless you.